everyone. I'm going to be giving you a gentle introduction to what gno.land is. Just a word about me first. I'm Leon. I'm a developer relations engineer at gno.land. I have about 3 years of experience in Web3, and this is my GitHub, and that's my graduation picture. And yeah, I have like block on my face. Okay. Right, so what is gno.land? gno.land is a blockchain, a new blockchain that was founded by Jae Kwon. And it is running a custom virtual machine called the Gnow VM, which allows for writing smart contracts in a new language called Gnow, which is basically a interpreted and fully deterministic version of Go. Okay, so that means you can write smart contracts in Go, kind of, right? So why would you want to do that? Why did we choose Go as a base for a new language, let's say? First of all, Go is very simple and straightforward as a language, and it has a very minimal learning curve. So new developers who come in can learn it very, very easily. Anybody? Okay, first of all, let me ask you a question. Who has written any sort of Go so far? Most people? Okay. Who has written any sort of C-like language? Okay. Well, that's the point. You know, Go is based sort of on C, so if you get any kind of C syntax, it's very, very easy to learn. Go has a large developer community, so Go, as far as I know, I believe it was launched in like 2009, so about 15 years now, 15 years ago. And it has a lot of documentation, a lot of tutorials, a lot of resources in general for learning that can be basically used one-to-one with Gnow, because the syntax is basically the same. That's the whole thing. That's the whole point. Also, it has a very solid collection of performant, well-known standard libraries. So Go developers know how to use them, and we use them in Gnow as well. That's the logic. And it gives a lot of power to developers in spite of its simplicity. So it can be simple, but it still gives you a lot of power to manipulate code the way you want. Okay, cool. And this is Gnow. So Gnow looks exactly like Go, right? Like this is basically Go syntax, and this would work, quote unquote, on as a Go package. On the left here, you see that Alice created a very simple package, and the definition on top is package Alice. And this is a package is basically a main organizational unit of code in Go, and the same follows for Gnow. The idea is that she then can define a package level variable, which, if any of you have written smart contracts in most languages, when you define something at top level, usually it gets persisted to storage. So the idea is that X will be persisted to storage after a transaction. Then after that, we have two functions. We have a getter and a setter function. It's obviously very simple, but I want to go through this to just show you the syntax and what all of the syntax actually means in Gnow. In the case of Go, once you write a function with a capital letter, that means that it's exported. So that means that somebody from the outside, so somebody who's not in the same package, can actually call this function. So the same goes for Gnow in the sense that it first exposes the code to other code, and then on the second point, it exposes code to users to call it directly, from a client, from a wallet, anyway. So in this case, then Bob can write his own package, which imports Alice's package. And so let's say that Alice already deployed her package on the chain under this Alice package name, right? And then Bob can import it and just use all of the exported functions. So for example, increment Alice would be taking X from Alice and then calling Alice's function to increment it, or just add one to it. So it's quite simple, but the idea with Gnow is that you can use the native features of the language itself, of Go, essentially, to have all of these very practical things. Like, for example, in Solidity, when you define a function, you have to specify if it's public or private or this or that. And in Go, it's very, very straightforward, very simple. And the same applies for Gnow. Okay, a little bit more about Gnow. So Gnow was modeled after Go 1.18. It currently does not support generics or Go routines. So this is something that we're actively building and thinking about. And Gnow is interpreted, as I mentioned before on the first slide, or the second slide, or the third slide. The idea with interpretation is that it allows for on-chain composability. I'll talk about that in just a little bit. But the next important point is that all code lives on-chain at a specific package path. That's what we call it. And for example, this is a package path. So you can essentially identify a specific piece of code on the gno.land network by a package path. Just like you would, for example, say an address for a smart contract in Ethereum. In this case, it's a package path, although we do have addresses as well, which I'll talk about in a bit. So this is the anatomy of GNO package path. Essentially, the first part, the gno.land part, is like the base domain, which is essentially the current official domain of gno.land, while maybe in the future, if somebody chooses to launch a second version or a different version of the gno.land network, it could be like Leon.land or something similar, right? So that's the base domain. Then we have the type of package. In this case, it's R, and I'll tell you a little bit more about that in just a bit. It can be R or P, and I'll show you in the next slide. But then you have the namespace. So for example, in this case, it's Leon because that's my name, and I want to publish something under my name. And the idea is that the namespaces can actually be nested, so you can, for example, say Leon/myapp/v1/v2, whatever, right? So you can actually have depth in the namespace. And then at the end, you have the package name, what you defined at the top of your code. It should match the end of the package. Okay, so let's talk about how code is organized on gno.land, or GNO. The idea is that you have kind of 4 or 3 main things. So first, I said that I'm going to explain the type. So the types are R and P. R means realms, so it stands for realms, and it means basically stateful code. The idea is that this code has some sort of state, and it can modify that state through transactions. While on-chain libraries that stand under P, P means essentially pure. So these are just functionality libraries. So they have libraries. So in the libraries, you can have structures, interfaces, functionality on top of those structures, but you don't actually have any state. So the idea is that even if you try to modify state, somehow under this package path, it just won't happen because the virtual machines knows that the P namespace is just clean and it's not going to persist anything to storage. Okay, so as you can see over there on the right, this is some app that I have, and I'm importing a couple of things. On the bottom, I'm importing our demo users, and that is an app that we created, and it's basically like an ENS app. So it's an app where people can register a domain or a namespace, like I showed you before on this. So I could register Leon to my address, and then it would allow me to deploy packages to that specific namespace. And it has a persisted, let's say, a map or a slice or whatever, it doesn't really matter. In this case, which essentially holds all of the registrants. So it holds a user to a namespace, for example. And it has a state, that's the point. And then we have pdemo AVL, and AVL, I'm sure most of you know, but AVL is a tree structure, and this is simply a package, so it doesn't contain any state, but when you import it, you have access to a tree structure, which contains a node, and then you have the whole tree with the nodes, and you can actually use it as a map. And then you have strings and circonf. So strings is a very common Go standard library, as well as circonf, which is string conversion. And you've seen it if you have Go, if you have used Go before. And the idea is that most standard libraries that we have are pretty much identical to Go. So we can usually just take the Go code and just plop it in and change the file name to .gno. And it's going to work most of the time. Sometimes we have to change some little things to make it work, obviously, but one of the things that we do not support, for example, which is very useful actually in Go, but in Gno, it doesn't, we don't have it yet in the full power that it has, is FMT. FMT is the package to print stuff out to the command line and format strings, etc. The idea is that the native implementation of FMT in Go uses reflection, so currently we do not support reflection. That is something on our plate. And the idea is that without reflection, you can't really have FMT. Yeah, that's the gist of it. I mean, we have some minor changes. For example, time.now. If you call the time library and you do time.now, it's not going to return the Unix timestamp of the machine because which machine, right? It's going to return the block timestamp. So we have these minor modifications to the language that actually makes sense in the blockchain context. And finally, we have this std package, which is a custom package or a custom standard library for the Gnow VM, which basically gives you gives you the functionality to handle anything chain related. So for example, you can get the message caller, the transaction caller, you can get the coins that were sent along with the transaction, you can get a block height, etc., etc. Right. Okay, cool. So let me give you an example of GRC coins. So this is basically, I'm sure most of you guys recognize this interface. This is the ERC20 standard for tokens, and this is how it looks like in Gnow. So you can basically define the interface just like you would in Go. And it's very simple in the end. Like you just define the interface by giving it the functions, giving it the return types and the arguments. And then the really cool part is that you can actually use it later down the line. So for example, this is a concrete implementation of a token that we're using. And the cool thing is that, as you can see, let me go back actually. So this lives under gno.land p demo grc grc20. So what does it mean if it's under P? Can somebody tell me? If it's P, then it doesn't have state, which means that it's a library, right? That's the idea. And there's a mosquito here, okay. Okay, so it lives under this package path, okay? And the cool thing is you can actually just take this link and look it up on the browser, and it's going to show you the source code. So I'm going to talk about that a little bit later, but that's the idea. So then if you take a look at this, you see that over there I'm importing it. So the idea is that this package actually lives on the chain, and my code can import it from the chain, right? And that's why the virtual machine is made to interpret, because it can actually compose code via the chain. So you can reuse stuff that actually lives on chain already without having to always recompile and always have all of the copied code in your local bytecode that you publish to the chain, like you do, for example, for Ethereum. Okay, cool. So this is the example, again, going back to the token itself. You can import the GRC package, and the GRC20 package actually exposes a couple of types. So for example, it exposes the banker type. The banker type essentially allows you to have admin functionality over a token. And if I took a look, well, actually, let me just show you, because it's a pretty cool demo. I wanted to show you the actual implementation, but okay, point is, the banker struct actually has the state of the token. So for example, it has the balances, it has the allowances, it has what else is there in the GRC or the ERC package, right? So it has all of the things that you need that you could modify as an admin. And then you have the token down below, which is another struct, which basically exposes something that's non-admin. So it's like safe stuff. So for example, you can use that to call, well, token is this, right? This is token. So it allows you to, it gives you the basic functionality of the GRC, while, for example, the banker, the banker gives you mint, burn, right? That kind of stuff. And we wanted to have this separation because this way you can actually expose these objects. For example, banker is, in this case, unexported, which means that nobody can access it from the outside, but the token object can actually be accessed from the outside. So you could technically say, okay, if I import this specific package, which say lives under foo20, somebody can say foo20.token and then call whatever function on the token struct is possible, right? And these are the functions, right? This. And I'll give you an example of that right here. The idea is that you can have a registry. So for example, you can have a registry package that essentially takes in some coins, and it gives you a register function. The idea is that you can give it a path. For example, this is the way you'll identify the token itself. So for example, you can put in foo20 or the package, the path of the actual package that contains the coin, the token. And the idea is that then you can actually give it a token type, right? So what I was talking about just before was, if you have this as exported, you can actually give it to someone else, and then that someone else can actually say, okay, we can get the actual token struct and actually use it for something else later. And this basically just showcases type-safe composability over contracts, right? And as you can see here, so this is like a script that you can run. And the idea is that with this, you can import the foo20, which is the token that I just showed before, right? this one, and then it imports the registry, and then what you can do is you can call the registry and give it the foo20.token, which is exported. That's the idea. Okay, cool. So, gno.land is supposed to be, or is meant to be, the GitHub of the ecosystem, and why I say this is because gno.land itself demands that all code that is published to it is actually open source. And I'll show you exactly how that looks in a bit, but once GNO code is actually deployed, anyone can import it, anyone can use it, so do properly license your code if you plan to use it for commercial purposes, right? Okay, cool. So, displaying realm state with render. So again, realms are smart contracts with state, and the idea is that we wanted to give a minimalistic and universal web server or web UI for any smart contract that lives on GNO.land, and that is called GWeb. And I'll show you, well, I won't show you the demo because I don't have Wi-Fi, I'm sorry. But the idea is this. You can register, you can create a render function in your smart contract. So for example, this one is very, very simple. It just has a message that can be updated, and it has a render function which just returns the message. The message can be, or doesn't have to be, in Markdown. So in the Markdown format, so I could like add, for example, header tags or something else to it. And the idea is that GNOWeb can run as a separate service somewhere and essentially ask the network, hey, how does this path, this specific code or realm exist? How does it actually look when you call render? So when you do call render, it's going to return the state the way the developer defined it, and then GNOWeb automatically renders it out as Markdown. And if you do go to gno.land, the first thing that you see is like a lot of information about Gnow, obviously. But the cool thing is that is called, essentially it's called the GNO.land home realm. And the idea is that everything that you see there is actually from the chain. But on the other hand, you can still create custom front ends. We have a Gnow.js and TM2.js clients that are available in the JavaScript world if you want to create anything custom. Okay, cool. So I'm just going to quickly go over the tooling and the ecosystem that we have. So for example, we have GNOKey. GNOKey is one of the primary used tools, actually. This is a keychain and client, so it's a CLI tool. It allows you to create new GNOW addresses and manipulate them in many ways. You can delete them, generate them, import them, export them, etc. It allows you to sign things. It allows you to also make transactions. So sign is basically the predecessor. So you sign something and then you can publish it. You can split it up into multiple pieces, or you can just do a transaction with make.tx, which does everything for you at once. And you can also query the chain with ABCI, which, for example, you could query the state of a contract or the render, or for example, you can evaluate an expression, or you can get the files that the contract has, et cetera, et cetera. So this is all the things that the blockchain actually exposes. Okay, then we have GNOdev, and GNOdev is a really cool tool. GNOdev is actually an all-in-one local development environment, and it basically brings up a couple of things when you run it. So you just run it, and you see that it starts a node, and it starts GNOWeb as well. So the idea is that with it, you have a local blockchain node that actually pre-mines funds to your accounts that you already have with GNOKey. So you don't have to, for example, in other tools, you would have to use some specific private key or some specific mnemonic phrase that one will be pre-mined. But this tool, GNOdev, actually takes your keys that are local and just pre-mines directly to them. So it's very, 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 very cool to use. And then it automatically also brings up GNOWeb, which means that now you have a blockchain node that's local, and then you have a GNOWeb server, and you can actually watch what's happening while you develop. And it's really cool because also it has automatic code reloading. So it can watch a directory and has some really cool mechanics behind it, which actually save the state in between transactions and your code changes in GNOW. Okay, cool. Right, then we have an indexer. This is more on the infra side, but it's really, really cool. The indexer is a indexer, which indexes the GNOW chain. Well, actually, it's a TN2 indexer, so it can index any TN2 chain, but in our case, we index GNOW. And it actually lives on this link, so you can actually check it out, for test 4 specifically. And the idea, or the really cool part about it, is that actually it has an integrated GraphQL interface, so you can actually just query everything through GraphQL and just have all of the data from the chain. It's super fast, so it's really good. Okay, then we have the playground. The GNOW playground is a very simple web page. It lives on play.gno.land. And the idea is that you can use it to play around with GNOW code. You can share it. So if you click share, it's going to basically generate a static link that you can share to people, and it's going to show the exact same code that you had when you clicked the button. You can deploy code via Playground. You can format it. You can run stuff, run expressions. You can test stuff, and you have access to a REPL as well. And yeah, that's like the very, very short gist, but we have more things. Obviously, we have, for example, a tool for archiving transactions. It's really cool, which GNOdev actually uses, et cetera, but I'm just trying to give you a brief overview. And we launched Test 4 in July 2024, so that was about a month ago, and it was a very nice experiment. You can check it out at test4.gno.land. It's a stable testnet that you can use today. And then on that testnet, we have some of these are actually projects, some of these are libraries. We have Adina Wallet, which is a custom web wallet that you can use to interact with GNOW. We have GNOWSwap, which is in beta right now, which is a swap, right? We have GNOWScan, which is the blockchain scanner. We have the native kit, which is it's a library for creating mobile applications with GNOW. So it can give you the APIs to connect to GNOW via mobile. And for example, I don't know, I'm not going to go through all of them, but those are some of the big things that are happening currently. And consensus. So this is a very interesting topic. After working for a couple of years on proof of stake, we realized that we wanted to build something that's maybe a bit better and more secure, because POS in the end can be bought out, right? POS can be cheated with money. If you do have a lot of money, if you're a government, if you're somebody who does have a lot of power or influence over people, you can technically just buy out the consensus. And GNO.land will probably not be secured by POS. So what is the idea? The idea is that we're currently in the process of defining a consensus mechanism for GNO.land, and it's supposed to be more resistant to subversion and still reward participants of the project. The idea is that we want the chain to be owned by a DAO. So when you have the chain, if you want to launch the chain, you essentially launch it with a DAO system embedded inside of it. So it's not going to be like a separate smart contract that's like sometimes later released, blah, blah, blah. The idea is that we want a chain that's governed by a DAO and that it fairly rewards the people who are actually building it constantly. So currently, Test 4, I believe, is secured by 7 validator nodes, all of which are prominent and active contributors to GNO.land. So this is kind of your call for contributions. The idea is that we're really looking for people and early adopters to contribute to GNO.land, and this can be in very multiple forms. It can be from, marketing material to tutorials to core protocol level stuff, et cetera, et cetera. So we're really open to anything, and we want to build with you, and that's the whole point. Thanks. That's it. You have some links here. Gno.land again, GitHub. This is the main repo that's having all of the activity basically. So in there we have, it's called the mono repo for a reason. We have the virtual machine, the GNO.land nodes, the blockchain nodes, and many more things in that. And then we have a Discord server, where we actually host office hours. So if anybody does want to come and talk to us every Thursday at 2:30 p.m. European time. And any questions? I know you guys are late, but it's okay. So if you do have any questions, please, now's the time. Okay, cool. Oh, sorry, yeah.
You were talking about using thanks. Can you hear me? All right, cool. You were talking about using GraphQL to query the data that you could, and would you be able to use any other alternatives besides that? And for what sort of purposes would you try to extract this sort of data for?
Let me see if I'm understanding the question correctly. So this tool that I mentioned is just an indexer, which can hook up to a GNOW chain and just index the whole chain, right? And it just exposes an API to actually interact with the data that it indexed. I'm not sure what your question is. Can you repeat?
So basically, like, what I meant was like whether you'd be able to ensure that the data would be clean enough to be able to extract what exactly, like, the sort of data that you'd be after.
Okay, well,
or like whether it's like, if it's just to ensure that it's not noisy or not noisy data or
no,
that sort of thing.
the way the indexer works, it literally fetches block by block and indexes all of the data inside of it and just packs it up properly in a local database where the service lives, and then it exposes a GraphQL API, which is also defined, and it's defined by the types that we have in Gnow and gno.land. That's the idea. Yep.
If you want to ensure that the data is good, you can run a full node locally and the same indexer.
Yep. Cool. Okay. Anybody else?